And welcome back to our Math Explainer. Today, we're tackling a super cool concept, equivalent ratios. Now, if you already know that a ratio is just a way to compare two different quantities, well, you're literally in the perfect place. We're going to see how two ratios can be perfectly equal, even when they look completely totally different, and more importantly, how you can spot them. All right, to keep us on track, here's our roadmap for this explainer. 1. What are equivalent ratios? 2. Simplest form and equivalence. 3. The magic of missing numbers. 4. The golden rule. And 5. Some practice questions to lock it all in.
Okay, let's dive right into section 1. What are equivalent ratios?
So equivalent ratios are basically just ratios that look totally different on the surface, but deep down, they have the exact same underlying value. You know, in math, appearances can totally be deceiving. You might be staring at two completely different sets of numbers, but when you really peek under the hood at the mathematical relationship between them, you'll find that their constant core value hasn't changed at all. It's really all about proportion. Let me show you what I mean. Let's start with a really simple ratio, 1 to 2. Watch what happens when we introduce a multiplier. If we multiply both sides of that ratio by 2, boom, we get 2 to 4. Multiply by 3, we get 3 to 6. Multiply by 4, and we hit 4 to 8. See what's happening? Because we applied the exact same multiplier to both the left and the right sides of our starting ratio, 1 to 2 is mathematically identical to 2 to 4, which is identical to 3 to 6, and yep, identical to 4 to 8. They look like totally different sets of numbers, but their core value hasn't changed a single bit.
Moving right along to section 2, simplest form and equivalence.
Okay, imagine we have a massive fruit basket with 4 apples and 12 oranges. That gives us a ratio of 4 to 12, right? But to really understand the core of this relationship, we need to find what we call the simplest form. We do this by asking ourselves, hey, what's the largest number that divides evenly into both 4 and 12? Well, the answer is 4. So divide our 4 apples by 4 and we get 1 apple. Divide our 12 oranges by 4 and we get 3 oranges. So our simplest form is 1 to 3. This tells us the fundamental truth of this basket. For every single apple, there are exactly 3 oranges. And you know what's really wild? We can take that simple 1 to 3 ratio and scale it right back up. Take your 1 to 3 ratio, multiply both sides by 2, and you instantly get 2 to 6. 2 apples for every 6 oranges. Multiply that base ratio by 3, you get 3 to 9. Multiply by 4, and we're right back where we started at 4 to 12. This is literal proof that 2 to 6, 3 to 9, and 4 to 12 are all equivalent ratios, stemming directly from that foundational 1 to 3 relationship. Just to quickly reinforce this with one more fruit example, imagine you're at the grocery store and you grab 2 bags of grapes and 4 bags of mangoes. That's a 2 to 4 ratio. Let's simplify it. Both 2 and 4 can easily be divided by 2, right? Divide the grapes by 2, you get 1. Divide the mangoes by 2, you get 2. The simplest form is 1 to 2. It really is that easy. And from that 1 to 2 ratio, you could literally multiply up to find endless equivalent ratios.
All right, section 3, the magic of missing numbers. Let's play detective.
So here's a fun little puzzle for you. We know that 8 to 12 is mathematically equivalent to a mystery number to 24. How on earth do we crack this? Well, we look for clues in the numbers we actually have. We have the second half of both ratios, 12 and 24. Ask yourself logically, how do we get from 12 to 24 using multiplication? We multiply by 2. And because we absolutely must keep the ratio balanced, since 12 times 2 equals 24, we have to do the exact same thing to the first half. So we multiply 8 by 2, which gives us 16. The complete, perfectly balanced equivalent ratio is 8 to 12 equals 16 to 24. See? That's how you solve a missing number puzzle. Let's try one more, but this time, let's flex a slightly different muscle and use some reverse logic. The ratio 9 to 6 is equal to 3 to our mystery number. Again, find the connected numbers that we already know. We have the first number in both ratios, 9 and 3. How do we go backwards from a larger number like 9 down to 3? We use division. Specifically, we divide by 3. Since 9 divided by 3 gives us 3, we just apply that same operation to the other side of the ratio. So 6 divided by 3 is 2. Yep, the missing number is 2, making our final mathematical statement 9 to 6 equals 3 to 2. I mean, look at how incredibly easy it is when you know the trick, right? It's just a simple matter of matching up the sides, finding the operation, and applying that exact same math to the missing side. Which brings us to section 4, the golden rule. So here is the ultimate cheat code for solving literally any equivalent ratio problem. Whatever operation is applied to the first part of the ratio, the exact same operation must be applied to the second part. I'm actually going to repeat that because it's absolutely crucial. Whether you're multiplying to scale up or dividing to simplify down, doing the exact same thing to both sides is the golden key to keeping your ratios perfectly balanced. Now, you might be sitting there wondering, okay, but why does this matter outside of my math textbook? Well, we use this logic all the time in the real world. Just like the example in your materials where rectangle heights are compared, understanding equivalent ratios lets us quickly scale things up or down in daily life. Whether you're comparing the capacity of two different water tanks, calculating your distance over time for a massive family road trip, or, my personal favorite, adjusting a recipe because suddenly 5 extra guests showed up for dinner, converting ratios to their simplest form makes complex comparisons incredibly easy to manage. All right, time to pass the baton. Section 5, practice questions.
Here is your challenge for the day. Number 1 asks you to simplify the ratio 6 to 18. Number 2 is finding 3 equivalent ratios of 2 to 5. For number 3, find the missing number where 4 to 8 equals a mystery number to 16. Finally, number 4 and 5 ask you to simplify 15 to 25 and write 2 equivalents of 12 to 18. I want you to go ahead and pause this explainer right now, grab a piece of scrap paper, and solve these entirely on your own. Take your time, apply that golden rule, and I know you've totally got this.
Welcome back. Just look at everything we've covered today, from foundational definitions to finding the simplest forms to tracking down unknown numbers using the golden rule. If this explainer helped clear up ratios for you, be sure to hit the like button and subscribe for more. And I'll leave you with this. The next time you adjust a recipe or compare prices at the grocery store, ask yourself, how much of the world around us is really just the exact same simple mathematical relationships, scaling endlessly up and down?
Thanks for watching. Bye, students. Don't forget to subscribe for more math fun videos. See you in the next lesson.